Our next guest on the Big Data Week stage is Mihai Cislariu, Head of Data Analytics at EPAM Romania. Mihai has been working with big data tools and teams for 5 years now in real-world business solutions from batch processing to real-time data streaming. In his current role, he's focusing on team growth, supporting developers, analysts, delivery managers, and consultants in their future career path. Today, Mihai will show us how we can better use big data, more specifically data science, towards optimizing infrastructure costs and increased customer engagement in streaming platforms. This should be interesting. Mihai, you're on.
Thank you very much. Thank you for your kind introduction. So, good morning, everyone. I hope you, okay, so now you see the presentation. So, hope you already enjoyed the morning coffee. If not, let's drink the coffee together and maybe with a cup of data aside, right? So, my name, as it was previously said, is Mihai Cislariu, as also the slide says in the bottom. I am the head of data and analytics department at EPAM. So just to give you a little bit of context about EPAM, and we are working on a very big scale projects together with niche company. And usually we are some dreamy kind of guys that are trying to innovate everything that they touch and everything that they go in contact with, right? There are more than 2,000 EPAMers in data and analytics department all over Europe. And we are looking to expand more and more since everything is in this era, in this new era of data we live right now. It's evolving very fast. So I'm happy to lead the team in Romania. This is just a little about me. Keep in mind that if you love working with data, sky's the limit. You can do everything you want and just be great. So about the presentation, today we will discuss about some services that are very used, are the most used since the pandemic is here, and this is the streaming platforms. You know, from the 2019 when the pandemic started, each one of us was staying home a little more than usual, and then a little more than a little more, and so on. And we start watching movies, we start watching sports, we start watching gaming, and a lot of this kind of stuff. So we'll discuss about the infrastructure needs to scale and how important is that in very big events like desired movie launch or very big sport events, and understand how to predict this case of events to optimize the cost, because basically we're on a business track and I think we need to talk about the figures, right? So in this presentation, we'll have a few steps. The first is the introduction, where I want to state our goals. I want to state what we started with. Then we will go through a little of architecture. Architecture, I promise you, it will be very, very less technical, and I will just try to explain how we build everything. And then we'll start with how we understood the problem, the platform, what we learned from the platform. And in the final, of course, we'll have the prediction of the future traffic. Last but not least, the last two topics, I think, are one of the main important parts here. It's about labor saving and cost optimization, which reduce the figures and how we win money doing this. Okay. So in the introduction, we'll speak about the part of the goals that we wanted to achieve and how we saw the situation. Our goals in this project were to make infrastructure scaling decision easier and also quicker using data and to optimize the costs in the long term. And this was done by minimizing the allocation of resources needed for non-pay-per-view periods. You know, pay-per-view are very demanding periods in each streaming platform and needs a huge infrastructure to sustain them. And having a stable connection for this kind of business and services is one of the most important customer satisfaction in this domain, because we all watch movies, we will watch sport, we will watch a lot of things over the internet, and we don't like when everything is clutchy. We want 4K, maybe 8K resolution, and we want everything very smooth. So in terms of customer satisfaction, this is one the main point of this kind of companies. So we started to understand the user behavior and a customer's interaction with the website. Usually any kind of a website is his actions, and his actions are the traffic that we track, we store, and after that, of course, we leverage it because we can find patterns and anomalies in the traffic, curate them, and use it further on for a lot of other procedures. Also, very important is to understand the platform system, how it works, what is the benefits of it, what data can we get from it, and so on. And we can find the expected load after the big events, pattern changes from releases, and so on, just from understanding the platform, right? And as expected, when you need to scale an infrastructure, when you need to know how many servers do you need, how many, I don't know, people do you need to support that. Usually we go to technical experts like architects and team leaders in the company. And also we get into this, the non-tech experts like business staff that is estimating what the number of the people should be based on social media, based on different kind of tools that they are using right now. And we do that to obtain an answer about the needed hardware costs, people, and so on. So this kind of process takes a lot of time, and without using the right tools and the right instruments, you will not know if they take the correct decision, and it can result in a, I don't know, a hazard from time to time. And this is something that impacts the end customer, and we don't desire this. So I promise this is the part that we won't go any technical. I just want to explain that from the beginning we set our goals, we understand what we want to do, and based on this we started working and creating an infrastructure. So you can see here a very high level architecture, which was made purely on cloud on AWS. So it can scale or upscale or downscale whenever we need. In the first part, we have the data sources from the platform first. So we read the APIs from the platform and getting all the information about traffic, events, and everything that is happening there. We also have an API about events. Events is referring to what is going to happen in the future, what kind of, I don't know, what kind of event we will see, a football match, a gaming session, anything like that, that is going to require a high load of user interaction. And also we get all the data from the S3 logs that are saved there, because it's easier to save in an HDFS environment. So for the data ingestion part, let's say ETL, we use the Amazon Elastic Container Service, and we orchestrated that using to orchestrate as an orchestrator for Amazon EMR, and we schedule everything using Apache Airflow with a custom ETL in place developed in Python. So all this data is ingested in a raw layer, right, in HDFS, in S3, and further on it is used for data analysis, ETL for data applications, and also for machine learning pipelines, which is the main point here. In the next part, we have the central storage, and here we have 3 layers. All of them are stored in HDFS in Amazon S3. The raw data is coming from the original data source through the data ingestion part, and prepared data and trained models are coming from data applications, once from the ETL in that area, and the second is coming from the machine learning pipelines, the data applications, right? In the third part, let's discuss a little about the data application, which is split in ETL and machine pipelines, in machine learning pipelines. So the ETL, we take the raw data and transform it and ingest it for our needs. Once the prepared data, and after that, we also have some information going into the data products like actual traffic, actual running task, event calendar. So in the second part of the machine learning pipelines, we take the data prepared in the previous step, right, in the ETL, and we apply machine learning algorithms against it in order to obtain trained models, which are further going into the ETL again, so we can just go to put it in the staging part. Okay, so you can see above the data application, we have a separate part that is called data analysis. And this is something outside of any production part. We prepared this zone as a dedicated for analysis, where we can do ad hoc queries. We can investigate irregularity data from the central storage, also test the data before going into production. Basically, we can test different new models in Jupyter to reduce the error. And after that, we can move everything into production without affecting any user interaction, any end user. On the bottom part, you will see the management and operation. So here we use GitLab for storing the code for different ETL operation and also versioning the code. We pick TipCity for continuous integration. We also choose Amazon CloudWatch. That is very important in this process because it helps us analyze all the Amazon infrastructure in place, like, I don't know, virtual machines, orchestration layer, S3 operation, and so much many. So, and the last part, the data products, it's where we have all the reporting layer, and it's residing in Elasticsearch for a better accessibility, for Grafana, where that is where the final user, the business, the infrastructure team, and anyone that is interested in this data and is generally taking decision based on this data can view, understand, and use their knowledge to take decisions about the future. And I promised you, this is all that I have in the technical part. Just to make a summary, we take the data from the data sources, we ingested it, we put it in 3 separate layers, we apply machine learning algorithms, and further on we move it into some dashboards for users so they can understand and use everything that they need to take actions. So we started to understand the platform, and this was one of the most important parts, because based on this we can do everything in terms of going on with the further predictions. Here you can see a traffic, how we see the irregular traffic. So let's call traffic that doesn't follow like periodic trends or seasonal trends as irregular traffic, and significant irregularity of traffic as an anomaly. This is an example of traffic of fit. So we can detect some irregularities there. You know, you can see all the yellow boxes here that is irregular traffic, but not all the irregularities are significant enough so we can so to send alerts to people. But all the irregularities are very interesting to better understand traffic patterns. So we take everything into consideration, and if we see that there is something that is not so important in terms of alerting and in terms of predicting, we can filter out later in the project, as you already saw on the architecture schema. So here we look everything from 2 main perspectives. What is the business value, which is very important, and what we can bring, and what is the actions or the implementation, because we're on a software development part. What is the implementation that we can make to reach that value? So as I stated in the beginning, one of our goals is to have a quick reaction on scaling the infrastructure with minimal to zero impact for the end customer, the consumers. And also we want to keep the cost as low as possible, because this is the second part of what we propose, right? So we started detecting the anomalies that we see in the traffic trend using a heuristic approach. And as we look at the events, we notice there are a lot of different types, like, I don't know, short outages, missing data, increases or decreasing in platform use with no reason, and a lot more. So for a better understanding, we put them on a dashboard. So as anyone who is working with data right now should do, because from my perspective, visualizing problems is the first and most important step to solve them. So after that, we excluded everyone from the machine. We excluded every one of these anomalies from the machine learning training, and also from the validating data set that are used for the prediction. And in the following part, we implemented a load simulator. The load simulator estimates the load for each service and what is the recommendation for the infrastructure scaling. This is exactly what the company and our client needs to see. And we also integrated the system with all the data sources about traffic irregularities, as you already saw in the architecture schema. And this is the final part when we start to predict the future traffic. And we start to predict how much infrastructure we will need in order to achieve very, very low costs and very high performance demand from the users. And here we split this in direct user traffic prediction and triggered user traffic prediction. So for the direct one, our goal was to obtain precise user traffic prediction and have a better understanding of all the traffic anomalies. Because as good as we get at detecting and understanding these anomalies, the better prediction we get, right? This is data science. So we started implementing a machine learning model to predict split user traffic in multiple components on different levels of hierarchy. So we split it in web and mobile, in type of events, and in subtype of events. And I think this was very important, because when you try to understand what you will need in the future, you will need to understand everything at the lowest level possible, so you can take the best decision in these kind of cases. So for the trigger user traffic prediction, we implemented an automatic recalculation that is using triggers for data ingestion, algorithm recalculation, new recommendation. We also have a manual feature for business to run and obtain the recommendation exactly when they need it, because we somehow saw that there are some events that they don't know before it's already 2 days before, and they need to know how to act, and maybe we don't have any information about it so far, and the machine learning the algorithms didn't use that event that is going to coming for the future prediction. And this is why you always need to have a way to manual action this kind of features. So we're moving at the business part, where everyone in this business track, I think it's important. Usually when senior management, business stakeholders, everyone is asking about what you obtain. So they say, I gave you a lot of money, a lot of resources, you bought a lot of servers, you used a lot of people for development. Okay, what's in it for me? What did I win with this? And here, in general, there are more than 20 FTEs involved in the decision making of scaling the infrastructure, and usually they don't take a lot of factors into consideration. So this leads to a loss of manpower, and also from time to time we may have poor estimates, because not taking a lot of factors into consideration will usually lead to poor estimates and poor quality. So we don't want that. So we developed a single view dashboard for analysis of the traffic. We can see past and future, because it's very important to see how what happened in the past, and to see what we propose for the future, and what we want, how we want to scale. And the level user of engagement and experience is also very important. We also provision the costs that is going to come for the next events. So everything is transparent. Everyone understands exactly what is going to happen, and they know how much it will cost what kind of traffic they will have, and they are prepared for everything. And because we work in an agile environment, new features are added at every iteration. So the entire company can use, understand, and take action based on this data. Because, you know, on your first try, you will have like an MVP, and they will all the business users will understand the value of it, and they will see what else can be implemented in that kind of dashboard or that kind of application in order to get the most out of it and to reduce more and more the cost. So our win here is the automatic scaling configuration that is always ready for production, and we eliminate human error and reduce the manual labor. And manual labor is, I stated before that there are more than 20 FTEs. They usually are 30 or 35 FTEs that are doing that in this kind of companies. So this is something that we got away with. And of course, the second part, it's about cost optimization, because when we talk about infrastructures, we talk about costs, and costs are huge in this area. And what we obtained here was a reduced infrastructure cost of 40% without affecting any user experience. 40% in a high company like streaming platforms, it's let me tell you that it's tons of money, and it's very important to obtain and to optimize everything that you can in this kind of environments, because huge savings are going to be obtained through data. And we also did a little more here. We split the infrastructure on very demanding events like pay-per-view events and non-pay-per-view events, so it won't be over-provisioned and very costly. Because usually when we have a high demand event, everything is going to keep the same infrastructure during the night, during the part of the past event time, and there's a lot of money that are wasted. And we use this infrastructure split so we can manage and switch all the infrastructure without affecting anything on the client side. So this is one of our success stories in EPAM. This is one of our projects using and leveraging big data and leveraging data science to obtain reduced costs in our client's company, and also to improve customer experience, which is again a gain of money, because usually happy customers are the ones that are coming back more and more. Thank you very much for being here with me and listening our success stories. I encourage you to go to our stand, because you will find a lot of interesting things there. There are a lot of games, and I think you will enjoy being there. Thank you very much.